Hello everybody at Reed LA. Hey, today we're going to talk a little bit about a synchronous motor job that we did a little while back for Barrett Goldstrike. 2500 horsepower General Electric brushless excitation sleeve bearing.
And during the training, if you have any questions, you can text my number 775-433-9390. And just remember there's a little bit of a delay, so we might be answering your questions a little bit late.
And that's Dan Custer from Reed Electric. Okay. What I'm going to basically do is just go through. You're going to get a chance to see some photos, and we'll talk briefly about each one of the photos as we go. So here's the mine, which has got a whole bunch of synchronous motors. You can just see all the blue area are the ball mills, and each one of them has a synchronous motor. This one right here is the mill, is the blue portion of it. The yellow covering is the guards that go on to the 2500 horsepower stator rotor area. The exciter is the part right behind the yellow fenced in area. There again is the ball mill. I'm sure most of you know what a ball mill is, but a ball mill is just a large vessel that has rubber liners on the inside of it and contains balls. And the large motor rotates the tank, and then they introduce the ore to it, and the balls beat the hell out of it. So in this photo right here, the exciter is on the left hand side. That is the rotating exciter on the shaft. It's the stationary fields, and it's also what houses the electronics for the rotor to rectify from AC to DC. There's a air line in the left hand side of the photo. That air line is connected to the shaft, and it has a set of bearings that allow it to rotate without jerking off the air line. The air goes all the way through the center of the shaft, all the way to the other end where the Wichita air clutch engages the motor to the load. This can only be done when the motor gets up to full RPM and has been synchronized. Okay. Here's where we've got the covers off so you get a better chance to see the rotor poles and the stator. This end of it, the clutch is on the right hand side in the photo. The red cable is a vibration probe that's attached on the pedestal, and we've got the top bearing chamber off where we're getting ready to prepare to take out the bearings and clean both of the pedestals. Okay, so for you that not have worked on one of these, that is a Wichita clutch. So the clutch on the left hand side is secured to the shaft of the motor. The clutch on the right hand side is secured to the gearbox that drives the mill. So both rotate separate of each other. Once the air is energized, the bags allow the disc to grab. They're like friction disc. And then both pieces rotate at the same time together. Again, you can see on the left hand side, the smaller part of the clutch rotates with the motor. The larger part goes right directly to the bearing on the other side of the clutch. Here's the other picture again, showing the pedestal. We're getting ready to actually pull out the RTDs and then start to roll out the bearing out of the chamber itself. Now, one thing I can tell you is that when these guys from the shop here go out, we have them take Nomex with. What we're doing is we're going to roll the bearings out of both ends and install the Nomex into the saddle so that when the shaft sits down, we only have the rotor with the insulation on it. So there's no path from the rotor to the pedestal, because the pedestals are both insulated, and we need to check to see if the insulation is good from the pedestal to the sole plate. The sole plate is the large square plate that the motor is bolted to and is part of the actual frame of the motor. So if you're looking at the stator in this picture, you'll see there's a piece of key stock welded on the left hand side. That large piece of beam with the two holes cut in it, that's the sole plate, and the pedestals are mounted to the sole plate as well on both ends. So it's just a large square piece of metal with two bearing pedestals and the stator in the middle. Okay. Okay, so here's the exciter again, and now we've got the rags out of the way. We're getting ready, like I said, to pull out the RTD, and then the plan will be to roll out the bearing, inspect the bearing, see what we can find out's going on. Bearing failed pretty severe on this one. We were looking with the covers off to see a couple of things, to see if any of the field coils on the rotor have seen any stress. So when you're looking at a synchronous motor, and I don't care if it's a brushless or a brush type with slip rings, any surge that's hit the rotor will cause the copper windings to put a gap in them or bulge and swell. The copper will expand and not come back. Okay, so a visual look is a real good idea to do on these, just to see if you see immediately something that looks like it's taken a surge. If you lost a field discharge resistor, or if you have an SCR that opens up in the wrong time period and is blown, you could introduce voltage from the stator as a transformer action to the rotor, and you could get some hellacious amount of voltage. It's not very likely, but you could get up to 80,000 volts across the rotor winding on a 4160 volt stator. That's our drive-in bearing. So a couple of things we noticed on it real quick was we have a shaft grounding problem, okay, as well as the rotor is moving. And in synchronous motors like these, you do not want the rotor to move, okay. The oil rings were bent to hell. You guys know all about oil rings. You can just take a quick look at that picture and see that they're not in very good shape. So one of the things I can tell you is we got two oil rings here, and I think you could take a good look at them and see this one is bent. You could also see the inside of the area is pretty scarred up from the shaft running on this with no oil. This is the other one, so you get a better idea. But you can also see by the right way would be to take your ring, hold it on a piece of paper, then turn it. And if you can see there, we've got lots of white over here, lots of white over here. It's definitely bent. This ring is not bent, and if I line it up, you can see a lot of the white spacing area over here. So Reed for many years used to take paper, draw the oil ring on the paper, turn it around all directions, make sure it's round, and attach it to the job. There was a lot of reasons for doing that. One, we could use that drawing if we were trying to put on trico oilers. We could measure from our shaft to the bottom of the oil ring and know where to do the oil settings with the trico oilers, because you only want 20% of the oil rings immersed in the oil. So this gave us a pretty good idea when it's assembled where to put it. If you didn't have that on there, it was a shoot match just trying to figure out where to put it. So it proved that the oil rings were round when it left. It was a big idea to make sure that we didn't have any wear on the ID of the ring, and that means that it's hanging up on the shaft and not spinning, which means you're not going to get any oil to the babbitt and start having the babbitt run really hot or wipe out very quickly. Okay, so on these synchronous motors like this one, both bearing pedestals are insulated. So underneath the pedestal is insulation. Both of the bolts are insulated with washers and tubes, and the dowel pin is insulated. So when we put the Nomex in where the bearing normally is at, we pull the bearing out and put a piece of Nomex all the way around it, we can now test the pedestal, and we can check it to the sole plate and make sure we have no path. Okay. This particular customer, when we got to the site, we told them did not have a ground wire on this end, and it has to have a ground wire on it during the operation of the unit. You can see a small nameplate in the right hand corner. The next photo is going to show you that right there in so many words says that the ground strap must be connected for the machine in operation. So you cannot have both ends insulated without the ground wire on one end when it's running. When you take the ground wire off and you isolate it, now you can test with an ohm meter to make sure that excuse me, the insulation is good between the sole plate and the bottom of the pedestal. And that has to be, otherwise you're going to have a shaft current issue. Okay. This particular customer swore up and down there's never been a ground wire on that unit. So we looked at the bearing here and we could see definite fluting problems going on with the bearing, as well as the unit was moving. It was hitting the thrust faces, going back and forth, which is a no-no. The clutch is so strong that when it energizes with the air, the disc can try to pull it to one direction or not. So it can't have any free play in it. So here's the unit where we're just getting ready to start prepping out the bearing pedestals, make sure they're clean and make sure that we polish the journal the best we can. Everything's being done in the field. They're not going to pull the unit. They're not going to let us take the rotor out and take it to a machine shop and do anything to it. This thing turns 200 RPM. So right now, all they want us to do is replace the bearings and anything that has to be replaced and anything we can do to stop it from thrusting and bouncing around. This particular pedestal that we're looking at right there in the photo, the whole pedestal was going like this when it was running. So the rotor would drift, it would hit it, and it'd flex. And it'd come back, and it'd hit it, and it'd flex. Can't do that. That's a definite no-no, okay? All right, here's again, we're just getting closer pictures up to show you that there's seal areas that we have to worry about. Right there in the photo, on the left-hand side is a blue color, and on the right-hand side is blue. Those are Bakelite seals bolted on. They could be aluminum, they could be Bakelite, G10, they could be any of that. But this particular unit has felt seals up against both inboard and outboard of the housing, plus the micarta bolted together to hold them, and they act as wipers to make sure that the oil don't get out of the chamber or dirt back into the chamber, okay? Another picture of the same thing. We're just being thorough on the photos that we're taking and taking better looks at how much garbage is in it and what we can do to clean them up, okay? So we're using a mirror in this photo, and all we're doing is going into the bottom of the shaft because we can't rotate the machine. And we're just making sure that there's no babbitt stuck on it, no scarring, no dents that are raised. Low spots you can live with, you can't live with anything high. Again, this is a low spot where the arrow's pointing, and this is where we've just gone in and polished up everything real good. And believe me, we've done this where we're not afraid of using a very coarse grit to start with and then going back and polishing it afterwards. So it's not impossible for us to use 100 grit to start with and get it down to a 400 by the time we're done. 320, 400, just for polishing it out, okay? Customer had the bearings. Now all we're doing is making sure that these bearings are the right ones. He's got many of these units, and who knows if the journal on one unit is the same as the next, or have they been machined different, okay? This is the actual bore size that was on the bearing in this box, and we measured it and came up with the same value so we could check the clearance from the bearing to the shaft journal in the field. There's our bearing again. You can see the two slots cut out for the oil rings on the bottom end of it, but it's upside down, just so you know. Those are the felt wipers I was talking about. So those would get bolted onto the pedestal on both sides of the pedestal on both ends. The micarta is what's being held onto with that felt seal between it and the housing. So the bolts are put in, tightened up. And that just, like I said, keeps the oil from trying to migrate out past the shaft when it's running, as well as the dirt coming back in. You have to be careful because that can really create some headaches if you got it too high. Your shaft will be trying to ride on the felt rather than onto the babbitt. Believe it or not, is maybe a 10-ton rotor or a 15-ton rotor even. That stupid little felt can actually stop that shaft from going down and riding on the actual babbitt. That is one of the wipers. That's the micarta that holds the wipers onto the housings. When it lost the bearing, that's what it did. So we had to have new ones made, and we did that right there at the mine site and bolted them on. So all of the red coloring you see in there, just so you know, is nothing but a red light on the crane so that people know the crane's above them. It drives us nuts when we're trying to look at some of the photos, so bear with that. But you can now see the micarta's back on the housing. The belt seal wiper is in between, back on it. A couple of things I can tell you, and I know you guys pretty well down there, but just listen. There's 4 bolts that hold that cap on. I went myself and unbolted the 4 bolts and took them out and got the crane just like they have in this picture here, except for they used about a 10-foot nylon sling. They put a clevis on the bottom with an eye bolt in it, I'm sorry, a hook, so we could hook on to the top of the chamber. Well, dummy me started taking it up, and the gentleman running the crane was right beside me, and I'd keep going, okay, give a little bit more, a little bit more. And what it was doing is it was stretching the nylon sling. The damn housing had RTV on it, silicone, and when it popped loose, it jumped up 10 feet. It nailed me under the underside of my arm, and I was black and blue for about 3 months. Lucky enough, I wasn't stupid enough to have my head over the damn thing. So my opinion is leave the bolts with a couple of threads all the way around on all 4 of them, almost all the way out, so that if it pops up, it hits the top of the bolts and doesn't hurt you. Okay, so if you look hard at the flat surfaces of the housing, there's curl T already put on the housing. That light is making it so it's pretty hard for you to see. The bearing is on top in the housing as well. Okay, and what we've done is we've gone to plastic gauge, and we've plastic gauged the 2 tapers. So if you look at the very top of this, you're going to see some shims that we've made, and there's 2 of them in this photo, right at 12 o'clock. And what we did though, before we made those shims, is we went in and we took plastic gauge. So I'm just going to show you some plastic gauge. I know you guys are familiar with it because you use it down there. Same way. So we've got basically a 1 to 3, a 3 to 6, and a 4 to 9 sitting here in this photo. And what we came up with was roughly needing 10 thousandths of shim to put in it so that the housing would clamp the top of the bearing without crushing it. You don't want any more than maximum 2 thousandths crush. You want metal to metal, 1 thou loose right in there. So just do the best you can to use your plastic gauge to do it. We have made a little tool up down here so I could explain to people how to use plastic gauge and what it represents basically. The plastic gauge is measuring either a clamp or a looseness, a clearance. So if I put shim in like I have here, these are 2 thousandths shim on this plate, and if I put the plastic gauge here in the center and I roll this over the top, I bolt it together so it's now one piece, and I tighten it up. The piece I stuck in there was a 4 to 6 right here, okay, which looks like this. So basically all I did was I stuck that in there, stuck the top on it, and when I got done I was able to see this line that I have here, and when I go over here to measure it, okay, it's right at roughly 7, being the white part of this measuring device, the width of this being 7. Well, 7 and 2 is 9. So it was compressing 7 thousandths right here, which is what I expected to have. So just remember, there's a huge difference in whether you're calling something tight or loose. So that's showing right there that it compressed, but it was only 2 thousandths total. So when you're looking at the shims, you got to kind of remember, look, this thing is a basketball. It's round, and they just give you those 2 little tapers for the housing to come down and crush on, as well as in the saddle. So we make these up, and I have them cut them like you see, so that there's not a possibility of having the shim pinch. So it'd be like having a shim here and a shim here all of a sudden being double the thickness if I'm not careful, because it got a kink in it. It doesn't want to lay if you just take a straight piece, put it on there. This thing's going to twist and go all over. So by taking a pair of scissors and cutting it out, gave it enough flexibility to go with the tapers and yet not crisscross itself. And let's say that's a 10 thou shim, that'd be 20 thou. That'll start distorting the bore pretty dramatic and start giving you a real problem with the shaft and that babbitt in the inside of the bore. And we've learned that over experience here. So you can do it in a circle if it's a round bearing. I mean, you know, we're stuck on this one with about a 1-inch surface area for the shim to go on. So we're able to roll it kind of over it and kind of custom fit it. And we're pretty sure that we've got in the shim that we want after we've done the plastic gauge. Okay. This is the exciter end. We're doing the same thing again. We're getting ready to pull the bearing out, clean it all up, make sure everything is good. It's another shot of it. New oil rings. They gave us these new oil rings. They were in pretty good shape, so we got them out of their stock. A lot of times you're lucky if you got a customer that has this stuff. Here's the housing after we cleaned it up. We were able to get in there and wash it real good. We got a vacuum cleaner, so we go in and suck all the oil and lacquer thinner and everything out of that chamber as much as possible. You can see the new micartas on the housings, but more so look at the way that the Nomex is in there. So now the shaft has no contact with the pedestal, with the bearing out of it, so we could test the pedestal to the sole plate to make sure that the insulation's there and that it's not grounded. There's a picture of the babbitt that came out showing a high spot. That's the new bearing going in. We kind of gone over the plastic gauge just so you know the different colors indicate the different thicknesses, and you can get plastic gauge almost up to 30 thou. Okay. So it goes in yellows, purples, and a whole bunch of colors I've never even used because we've never had that need. Sometimes if you're on the site and you have a job and you put your plastic gauge in you brought, and let's just say you go up to 9 thou and it doesn't make any contact, I would suggest at that time taking a piece of shim that you know is 9 thou or 5 to 8 thou, put it on, and then put your plastic gauge on top of the shim. Now you can see what you've got and you can add that to your shim. So if it's 5 on top of 5, you put in a 10 shim. That's just another way of trying to get you past where you've got a problem because you don't have the right, plastic gauge along with you at the time. Another thing I can tell you is that we've been using curl T for a long time up here. Well, with the generator guys that we've had a chance to work with from the factory coming into the plant, a lot of them are telling me that the chambers build up pressures and that they've had problems with curl T, so they've gone to ultra blue. Ultra blue is the silicone, and it is really pretty decent for a pressure problem. So if you've got a housing that you're trying to retain the oil in and you know it's got some type of a positive pressure built up into it, use the ultra blue over the curl T. Curl T works fine, and we use it for about 90% of the stuff still up here. Okay, but on generators, they are leaking like a Harley. So I'm telling you ahead of time, I would use the Permatex Ultra Blue on the generators or anything that you have a concern that might be a vessel that has some type of air pressure built up in it. Okay. This is a bearing chart that's right out of Professional Bearing. It's from Chris. I have about 4 or 5 bearing charts that I use from time to time on different jobs. But pretty much if we say it's a 7-inch shaft on that chart, on the left-hand side you'll see the 7 or the 7.000. That's the diameter. The tolerance is plus 0, minus 1. And the bore is at 7.014. So 14 thousandths is the total clearance that it can have max. Okay. Just as a rule of thumb only, but a pretty good rule, 3 thou plus shaft diameter will get you in the ballpark. This one's saying 14 is the max. So I'd be looking for 10 to 14, right in there, just to see where we're at. 14 would be the high end of it. And if I had a calculator, I could run through it and see if that's like 2 thousandths per shaft inch, or we're down to 1.5 thou per shaft inch where we're at. But ESA says shaft plus 3 is the ballpark figure. Okay? And it's quick and easy for you to remember. So I use that in just the back of my head. Okay. Okay, so here's the same journals that we've been cleaning up, and we've got them cleaned up a little bit better now, and you can see the chamber, the bearing pedestal is all nice and clean. We're getting ready to put in the other oil ring, and we cleaned up the seal areas, and now we've got the new micarta back on, and so on. Okay, so when we're looking at the pedestals, I'm going to show you something that I just brought in here for show and tell. This is a bolt with a washer. That would be the same thing you see in where the red arrow is. These then, we'll take the tube and we'll slide the tube up against the washer. Then we'll take these two and we'll slide that up. And what we want to make sure if we're making these is that we don't want this to be at the very bottom of the frame and start tightening this and try to crush the tube. So the idea here is to leave a small amount, and if you're looking at this in the photo good, you can see where the threads stop here, and it's probably got about 60 to 70 thou movement right there, that this could move a little bit, but it'll still tighten the hell out of it and just not crush, because it's going to end up on the belly of the pedestal. But we want to make sure that both of those bolts have this arrangement done on them. And if you look over in the right hand side of the photo, you'll see that there's a picture of the blue DMD material that's been underneath of it, trying to make sure it isn't grounded. Now look, my word of advice to you is that almost every one of these that we go out here on has people that like to use water hoses, or they have pumps that are above the synchronous motor that are called cyclone feeder pumps. They overflow constantly and pour water everywhere. So you could have a pedestal, it could have insulation, but it could also be grounded because the damn thing's wet. And this is the problem. You will have shaft current in it, and I guarantee it. So you're going to have to make sure, no matter what, that it is not grounded when you're doing your checks. Okay? And that's on both ends. So you should be able to get that on both ends. Now when it's running, again, you're going to want to tie your ground wire to the pedestal, to the sole plate. So now only one end is grounded during the operation. So here's a picture of the unit that was right next to this one that the customer said ours never had a ground wire on it since it was installed. Well, we showed him the unit right next to it that has the ground wire, and he goes, oh damn. So that motor we were working on has a ground on it now. Okay. All right, so this is the part where I'm going to talk to you about a little bit, because listen, there's gap disc and there's axial locking devices that stop our rotor from moving. So I know Albert goes out on these things all the time in the field, and if you can see anything moving, it doesn't have it or it has a problem with it. So on this motor right here that you're looking at in the photo, the pedestal, when it was running, was going like this. I'm making it dramatic, but you could put your hand on it and feel it going back and forth. And they said they could see the pedestal bowing. Well, I can believe it. This is 2,500 horsepower, so the rotor on this thing is 60,000 pounds. So it hits the face, and that little pedestal is going to move. So right now, in the photo that's up there with the circle around it, is a little drum that has flanges on both sides, and it actually has two spherical roller bearings internal, one on this side, one on this side. We clamp this side of it directly to the rotor in the motor. We clamp the other side to the clutch on the gearbox side. That holds the rotor, so the rotor will not move. If it doesn't have that in the middle, it's going to have a problem and take out the bearings no matter what. And it might take a year, it might take 6 months, it might be 2 weeks. So that, we're going to show you some more pictures. There we are bolting it in. This is right in the center of the clutch. Okay. There's your roller bearing on the left and one on the right, and they were shot. They were allowing this thing to move a good 1/4 of an inch or better. And when your shoulder and your babbitt's this far and it's able to go like this on the thrust faces, you're never going to fix it unless you fix that. A lot of people don't know what I'm talking about as far as this being the axial limiting device or a gap disc. If you didn't have that and you had a standard coupling arrangement, if the coupling can go like this inside and out floating and you put a gap disc in the center, it can't move like that anymore. That limits the float. So it's float limited. And the gearbox has got hard bearings in it, not sleeve bearings, so it's locked by the gearbox so it can't move. Okay? Dan, I'll let you read this. This is an actual drawing from Wichita. Point to the...
To the clutch?
Yeah, to the axial locking device.
To the anti-locking device right in there?
Yep.
Yep.
So right in the center of that, in the middle, you can see that's the device that holds the rotor from moving either direction.
So on here it says, the axial locking device is an optional feature offered by Wichita. This device prevents damage to the mill motor bearings during motor startup by axially locking the armature to magnetic center.
So that little jewel right there can save all the bearings in the world. And I've been on at least 6 of them that never had this. I've tried to get them to install them. I don't know why they fight it. They've always had a problem with it, and they don't want to fix it by installing that, so we just keep selling them bearings and labor. It's ridiculous. And I know Albert goes out a lot, and I'm saying that because I know he goes out in the field all the time. And I know he's seen this, and after seeing that, that might be something that he can help promote down the road too, to help stop having the same problems at the same places before they say, let's try somebody else instead of Reed. They're not solving the problem kind of thing. That's all I'm saying, okay? And between a gap disc or that locking device in the center of the drive clutch, or the clutch, could be the big difference of this thing lasting 10 years, 2 months, 6 months, whatever. It's really got to be something that's installed or kept there. I think that's about it. I just wanted to go through that. I would like to talk to all of you guys down there about the brushless excitation circuit. That's coming up in the future, but we'll go over the discharge resistors, the SCRs, the regular firing diodes, and how they work and what they do, as well as the brush type rotors that use slip rings. They have the same basic controls, they're just mounted elsewhere in the cabinet. And then you'll start realizing how important a discharge resistor is, because if it isn't of the right value, or if it is open, you've got a real problem. The discharge resistor is there to keep the rotor from acting like a transformer and having a very high voltage in it, but more importantly, it's there so that the rotor has enough torque to start. If the discharge resistor was removed and you went straight across it, it would start, but it would take about twice as long, and it may not get to the full speed. So
Again, if anybody has any questions, you can text 775-433-9390, and we'll wait a couple minutes here because I know we're on a delay to see if any questions come through.
absolutely. And I don't mind if there's any time I can help with any of you guys at all. I don't care if it's in the field or you're going out on the field, especially if we got photos, we could look at them together or whatever. I know you guys are well at what you do and everything else, but I can tell you, after working on some of these of my own, there's a lot I didn't know about it. So I'm just trying to pass the information on so that you guys had a better start. You don't go out and blow up a rotor by accident, or you don't, have to guess at something. Guessing at turning it on is real scary. All right, take care, guys.